Hello everyone, how to solve this problem for the values of k if we have k plus 7 whole square is equals to 64 and we solve this problem for all the values of k. So here we need to find all the roots of this equation and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So that our first method be the in the first method we solve this problem with the help of a square root. Here we need to apply square root on both of the sides, and when we apply square root it will be written as k plus 7 whole square and its square root is equals to square root of 64. Further, you see here in the left hand side, these 2 and this square root are gone, and we will get here this is k plus 7 is equals to, here in the right hand side we have this is 64, and when we apply square root on 64 it will becomes here 8. So the square root of 64 becomes 8, and further you know about that when we apply square root on both of the sides we will write here plus minus sign on any one of the side. And now we divide this equation into the two cases. The first case is we write k plus 7 equals to plus 8, and the second case is we write k plus 7 is equals to minus 8. From here we move this plus 7 to the right hand side and it will becomes 8 minus 7, and we easily get the value of k is equals to 8 minus 7 becomes 1. So this is the first root of the given equation, and in order to find the other root we need to solve this equation, and here we move this plus 7 to the right hand side and it will becomes k equals to minus 8 minus 7, and we get the value of k is equals to minus 15. So this is the value of k, second value of k. So here in the first method we get these are the two roots of the given equation, and now here in the next step we need to verify that which of the root are solution and which of the root are extraneous root. So for verification we need to copy down given question statement. Here it is k plus 7 whole square equals to 64. This is the given question statement, and here in the side we will be verify k equals to 1, and in the side we will be verify k is equals to minus 15. So we need to verify both of these two values, and first we verify k equals to 1. So when you put k equals to 1 into the left hand side it will be written as 1 plus 7 whole square is equals to 64 or not. This is the our claim. So we have 1 plus 7 becomes 8 square equals to 64, and here you clearly see that 8 square becomes 64 equals to 64. This means that both of the sides are equal, and if both of the sides are equal we conclude that k equals to 1 with the solution of the given equation. And here in the same pattern we verify the second value of k, and when you put this value here it will becomes minus 15 plus 7 whole square is equals to 64 or not. So for verification of this value here we simplify the terms, and minus 15 plus 7 becomes minus 8 whole square is equals to 64. So minus 8 square becomes 64 equals to 64. So this shows that both of the sides are equal, and if both of the sides are equal this means that the value of k equals to minus 15 is satisfied our given question statement. So it means that both of the values are satisfied our given question statement. So we finally conclude about that the solution set of the given question is 1 and minus 15. So this is the solution set which we get here in the first method, and now we again solve this problem from second method. And in the second method we need to copy down given question statement here, so that our given question statement is k plus 7 whole square is equals to 64. This is the second method, and our second method will be the very quick method, and here we quickly get the roots of this equation, and here we use the nice algebraic formula to solve this problem. So here we use this formula a square minus b square is equals to a minus b times of a plus b, So in order to apply this formula, first we need little bit simplification here, and we move this 64 into the left hand side, and it will becomes k plus 7 whole square minus 64 equals to 0. And here we again rewrite the above equation as k plus 7 whole square minus, we write this 64 as 8 square, and this whole equation is equals to 0. And now we are ready to apply this formula. So when we apply this formula, so this will be written as our first factor is a minus b, the base of this term is our a and the base of this term is our b. And when we use these two values here, it will becomes k plus 7 minus 8 into this is also k plus 7 and plus 8, and this whole equation is equals to 0. And here we have this is k, 7 minus 8 becomes minus 1 into, here we have k plus 7 plus 8 becomes 15, and this whole equation is equals to 0. So in the next step, we need to divide this equation into the two cases. The first case is we write k minus 1 equals to 0, and the second case is we write k plus 15 is equals to 0. So from here we easily get the value of k is equals to plus 1, and from here we easily get the value of k is equals to minus 15. So in the second method, we again get these are the two values of k. So in the first method, we already verified that these two values of k are satisfied our given question statement. So that here we finally conclude about that the solution set of the given question is 1 and minus 15. So this is our final answer of the second method, and I hope so you like this method. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.